Welcome all. This is a special masterclass just dedicated to mobile robot tow tractors. So Tugger trains, convoys, trailers. We will make a specific analysis for this kind of vehicles of the risk assessment for the vehicle itself, taking into consideration what are the relevant standards to take into consideration for the hook, for the vehicle. We will also have a look at what are the risks associated to the environment. We will see some videos, and all of this has to be with all the course that we have prepared from the legal point of view, liability point of view, the standards, that identification, evaluation, the risk reduction, and then they putting into operation how do we of the environment, the hazard zones, operating zones, all these things, all these concepts that we have learned in the course, okay, because this is what we see in the course, okay, the legal framework standards, identifying risk reduction, risks, etc., but applied to this vehicle, a tow tractor. In this case, it's a outdoor. It doesn't matter. It's a moving tractor, autonomous, whatever the navigation, it doesn't matter. And we go into detail about the risk about this specific vehicle. Sit down, listen, and learn, because Dave will explain us what are the relevant risks associated to this type of robot and how can we handle them. We're going to talk about the risk assessment in the tow tractors. Okay, Dave, let me just explain what is the risk assessment. So let's see if I have learned during these weeks that we have prepared. Okay, so we are going to talk about the risk assessment in tow tractor. We decided to talk about a tow tractor because it's somehow a risky
special vehicle,
special machine that has several associated risks that maybe another vehicles do not have. So we are going to talk about the risk assessment. So what it is identify these risks, evaluate them, so give them a value. They are very important, or they are who cares about these risks? Okay, so this is the part of the risk assessment. Okay, once we have identified this risk, and in the module 3 and 4, we do all of this very specifically. We explain how to do that. Then we go to the risk evaluation. So we say, not the risk evaluation, excuse me. We go to the risk reduction. So we say, okay, we have this risk. What can we do to remove this risk? Okay, or not to remove, or to put it as low as possible. Okay. This is all about the risk assessment. And in our case, in our specific case, we have, because we are talking about mobile robots, we are going to talk about the risk assessment in the machine that is done following rules on the standards. Okay. And we are going to talk also about the risk assessment in the environment, that there are also rules and there are standards, but each time are different, and are created residual risk specific to every customer, every installation. And this is done or by the customer, or by who is integrating in accordance with the customer. Okay, so while we are saying that the manufacturer is the responsible of the machine, and that is clear for everybody, then in the environment is the end user, together with who is installing, who is taking care of that, what is the contract, and then it's more, let's say, subjectivity. I don't know how to say, because there are many other things that maybe we could not even identify or not could evaluate, because there are people, there are many other things, no? So this is what we are more or less the risk assessment from the AGV point of view, and this is what we are explaining from module 1, 2, and up to module 5, because we are also taking into consideration and 7, the operations of the mobile robots. If we go into detail, okay, about the risk assessment on the machine itself, we know we have the 36914, which is the one that is leading the safety staff for what regards the mobile robots. Okay, and there are many things to check, stability, and we talk about that. Okay, in all the courses, but just focus in what is the person detection test. That is the most important, the most understandable and most relevant when it comes to mobile robots. We saw in the module 6 that we have this test A, test B, okay, that is done with the safety scanner or LiDAR or radar or whatever it is, okay, to detect if the AGV is able to stop before touching something. Okay, I will not go into detail about the test, because it's cylinder, it's horizontal, it's vertical, etc. What I want to say here is that also the tow tractor need to comply with this standard 3691 and with this kind of test. Okay, so we are sure that the vehicle is compliant with the 3691. Okay, as if it were a forklift or a platform, or who cares? Okay, this is
it's the machine risk assessment. Yes,
machine risk assessment, and all of this stuff. How this how for example, how do we calculate the risk if it is it's very important or not? There are the matrix, there are methods like the Kini, that just
you can use everything.
There are many things. Okay,
way, 12,100 ISO.
For the tow tractor would be nice. It's the same. I would say.
Yeah.
In what is the specific risk that I can identify in a vehicle, in a tow tractor? If we are going forward, nothing. Okay, for me. Okay, I would say nothing. It's a risk that is understood and is clear. Because we said that we have the 3691, we have done this test, and the vehicle is stopping here, no problem. The main problem in the tow tractors for me is maybe this one, that you are covering the front. Okay, you are covering the forward direction. But you are not covering what is happening behind, because typically these trolleys operators, they hook and unhook, and they are not connected between them. There is no safety between them. There is no barrier to go between them. If they touch you, typically there is nothing that will stop the vehicle. So this is a risk that is quite important.
And this is one of I'm not it's a gray area, let's call it, but in my opinion, the things to do, this is a scenario. This is one of the scenarios you can find in the new environment. Indeed, there are people walking between AGVs during their job and so on and so on. So this is already you identified your zones. You said, okay, operation hazard zone. This will be an operation hazard zone for sure, because it could be endangering people. Here is also a situation where or people and AGVs, let's say, working together. Normally, we try to separate this. You have one way for the vehicles and another way for the persons. Okay, so normally we try to minimum this scenario. If this scenario is happening, because the environment, in a factory, in an automotive industry or whatever, it's people and AGVs are working together. I will take this on like a pragmatic way, and I'm telling the customer, if this was at the AGV, we let's say it's a normal towing truck with persons, because now the new thing is the AGV. Before it was a guy on the steer, and he was driving through the factory. This one, it could happen also with a driver, because if you have a driver, he will go in one direction and see in the direction what he's going. He don't have eyes in his back, so he don't see if people are walking inside the trailer. What happens then? He has also the same accident as the AGV in this case. The only thing what is different, in my opinion, is if the guy is going inside the trailer and hurt, he will yell at the driver to stop. Okay, but the accident is already happened. The driver will stop and will check. Oh shit! Someone is stepped inside the trailers. This is in our robots. Will maybe in worst case, if we don't do anything about this, it will keep on driving, even if the person is trapped between the trailers and under the trailers. If we do nothing, all the trailers will drive on this person, or will hit this person several times. This is a worst case scenario, because the robot if he is shouting, he don't listen. So to see that our robot, let's say, is listening in the same way as the driver will do, and stop when the driver will stop, and before. If we can don't have the accident, it's even better. I will suggest two things. In my way, there is we need also the floor marking to have the zone dedicated to only trolleys and AGVs here. Don't walk there. Don't walk in front of the AGV. Don't walk to the trolleys. That's one of the things. So floor marking or marking anyway, traffic plan is one of the things. Training is also one of the things. And design, traction control, for example, of the AGV. If the AGV and the guy is there under or in the side of trailers, and the AGV start to spin or have another load than the normal one. I hope some things like that can help us. If it starts spinning, then we check. Okay, the load is too heavy, or somebody is trapped between the two cars.
Yeah, some kind of device that verifies what is the force, the pulling force in the hook, and stops the vehicle in case of abnormal force. I've seen those. I've seen those in some applications. The problem is that they are sensitive, and in normal operations, these tractors are going stop, start, stop, start. So the force they make when they start, the beginning is complicated to measure. No, the measure that you are mentioning is the almost the only one for this kind of.
And also
the application is not so easy.
No, it's not so easy. That's true. But that's one of the reasons they tell us if it starts moving, stop moving, then you need to speed for 0.3. In this case, let's say worst case scenario, it's at full speed. Normally, it cannot not be at full speed, but because we saw if in this one, let's say a person is between here, if we don't have 500 millimeters here, we are in a hazard zone, and it's telling us the speed can be maybe 0.3 or 0.7, only the maximum. So in this scenario, where people are walking between the AGV, and so we don't have here clearance then for sure, because I don't know why this one guy is walking there. So this should be done 0.7 in the hazard zone. My opinion also, I tell the most of the clients, and we reduce the speed generally to 0.7, sometimes 0.8. Anyway, just because you have the environment is always complicated, mostly with the towing tractors.
Another solution, Dave, that is to put some kind of barrier here.
That was what I was telling you. What is the second and the best option? Is indeed the design. Here also, when we start using white trolleys, for me, design is actually is number one. So if you design it in a way that's indeed it's also already rounded, that this guy can actually not enter in this area, because and if maybe indeed if it's only his foot, okay, it's not good thinking, or it's still an incident. But when the severity of this guy is very high, then I think you have an AGV driving at full speed. This one is then half ton or 200, 300 kilos trailer.
No, but you have to tractors of 20 ton, so.
Yeah, that's possible. But okay, but if I am a company and I have tractors of 20 ton, with in total 20 ton, I hope this guy is not walking in front or between my tractors of 20 ton. If this is the case, that's the one thing we need to. That's the reason I said gray area, because everything you said now is depending on the environment, of course. On the AGV. thinking this is a small AGV in the automotive area.
In this case, yes, of course, it's small, but there are tow tractors up to 20, 60 tons that are moving also outdoors. So
if this is in a harbor or something or whatever, or 20 tons, I will say here is a fence. And this tractor is driving here, and this guy is behind the fence.
What we are saying, for example, in tow tractors of 20 tons, because if you have a big trolley, you are not willing to, maybe you are not unhooking and hooking every time. So it's easier to put this kind of barriers between them. Maybe it's easier also to connect all the trolleys, okay? With the e-button, you can put maybe some bumpers here, okay? But
what we did already also with the client was put here like e-stop button, not a button, but a cord. You can have support.
This is the ideal in the solution. The problem then is that
in corners.
If you are in a, as you say, an automotive factory where you have hundreds of these, you connect them first. You need a lot of time to remove all the connections every time. Then you have to make all of this. If we are saying that this is something PLD, also this should be somehow PLD or something.
Person detection.
When you do the risk assessment, you say this is what you should do. You say you say how much does it cost? They say, okay, let's put some kind of training and confined area or restricted or something like that.
For me, it depends also. It starts indeed with your environment and also how many trailers you have here behind. If you have, let's say, 8 trailers behind, the risk of people walking in between the trailers will be maybe more because you have more trailers.
You have more slots. It's clear. That's how.
And also
the more trolleys you have, the more possibilities to get between two trolleys. That's clear. That's a good point.
But for me, the difference between scenario 1 and scenario 2, or you have a lot of let's say AGVs driving in a factory with a lot of trailers and small trailers and so on. And then your severity at this one, if you say, okay, it's in the automotive industry, you have small tractors, let's say, with good designed vehicles. The first thing is design. If you put here a design that you can't enter, this is the elimination of your risk is number one. That's safety by design. We
saw that in some model, no? The first
we saw that in the
design. If there is the risk, the best risk assessment is not to have the risk. So
But and the second one is let's say after elimination of the design, elimination of the hazard. Second one is put your risk in another way. So it's actually saying, okay, the AGV is driving his own path and the person is doing another path. Then you separate your risks from your persons. If you're telling me now, okay, we are here in some kind of area where we can't design it, we can't separate the persons. My opinion is, okay, now you need to do something, or the design should be done properly, or the e-stop system should be here on the backside, or you need to remove it from each other, people and AGVs in another area. And if this is all not possible, then for me the speed should be reduced, and we did this also with the client. Even there, where the speed was reduced to 0.3, and it says okay because it was going everywhere between every machine and every people and so on. And then sometimes because speed can be a safety measure. If you have time, even with slow speed, if you're standing here, it pushes you away from the and you're hurt, but not like if in the same way, then it's 1.2 meters a second.
One question: if you are the manufacturer, okay, you just certificate the vehicle, okay?
Normally, yes, and the hook,
and the hook, of course.
Yeah.
Then everything that is behind is not your problem.
No, that's the environment. So risk assessment environment is this. Risk assessment machine is this. Yeah, that's you can deliver this vehicle with a 3691 certificate, let's say, the CE declaration, and telling, okay, it has person detection, but you need to say the rest risks in your manual. You need to tell the client, okay, I covered this, but I did not cover this. So
this is important. So yeah. I'm thinking about this case, for example, I am not responsible. This is not my...
This one, it says in the 3691 also, and also in the 1117, that this trailer, let's say, need to stop also in a slope in every condition, and stop is also stopping. It need to also be in this designed that it cannot go backwards. Even
you have to have the brake. The brake.
That's the brake area. Yeah, in this case, if these two unlock, let's say, this is the same thing. If you do the risk assessment environment, we will have, let's say, this is PL performance level B. We saw it. This let's say this is a mechanical hook. This is a mechanical hook. It will be the most normal one. Yeah, you need to design it in this way, like our hook. Like this one, so that this actually cannot happen. But this is the customer. If I, it's different. If I'm an AGV manufacturer and I am selling this vehicle, okay, then it's this. If I'm selling this vehicle and I'm selling them also the trailers for my vehicle.
You are selling the trailers, yes, but if you find the trailers there, because typically you find them in the factory.
Yeah, in the factory, and they use a certain kinds of.
And sometimes you have to see them; they are completely a disaster.
Yeah, this is the risks that they need to cover in the risk assessment environment, and that's for the customer side. The only thing here is. What you can do as a product, your manufacturer of this, is that the brake is in this condition that it cannot go down. And I think also in this case, where the white trolleys are, we'll see also a video. This is, let's say, safety by design should be that the AGV is as big as the trolleys, for me. Because this can be happen as this guy is standing in the other direction and looking forward. Maybe this is, for me, it's not designed well. If I'm the AGV manufacturer and I'm telling the people who are buying my vehicle, and my vehicle is 1 meter wide, then I'm telling them also, okay, your car can also be 1 meter wide. Or I make here a system, we will see in the video, like a external bumper or something that you can extract. That this is not the case, that he will be pushed out of the zone, or even with a trip switch, that if here is a line, a bumper, let's say, that he will pushed out of and not be trapped inside of the car. For me, this is machine safety. Here,
so you're saying to put here some kind of
a bumper or
something that is covering the wire. Yeah. You always have this okay, but in this case, it's the same problem as here.
Yeah. But in this case, let's say this is a scenario, but this is for me, worst case scenario. This is why people are not trained to work with tractors then, because then you have done not all toolbox, no safety video, no floor marking, that you are not supposed to walk there. All these things you did not do as an employer, and then in worst case scenario this can happen. But then this will be when will people step in between two? But this one, if I'm talking to a person, let's say I'm drinking a coffee, I'm looking in the forward direction, and this, okay, the laser will normally detect me, but it is possible that let's say something was on the AGV. Was here. There is a an alarm on the AGV. I'm here. I'm the operator. I check. I reset the AGV, and another guy from the maintenance give me. Is telling me what to do or whatever, and we are standing here. We're making a small talk to each other, and then suddenly the AGV starts to move. Then we don't see it coming. You know, this is the hazard. Maybe in worst case scenario, I don't see the hazards here. The risk here. Normally, I see this. I will deliberately step inside of a hazard situation. Let's call it. In this case, for me, this should be by design.
But one question: you said by design. I understand it has to be as wide as the vehicle, or as the trolley. Okay, but practically, as a manufacturer, what can you do? You say, okay, these are the trolleys. Typically, you have tow tractors that are standard, so you are not doing all the widths of the tow tractors, and you can say, okay, this is my vehicle. Is wide like this. You can handle this. But you can do that. I mean, you are not saying that you cannot do this. You can do that, but you have to inform, to prevent, to do the risk assessment properly. I understand what you said. It's better to have the wider vehicle, but if you don't have it, you can in any case sell it, knowing that there is this risk.
That's true. Yeah, you can. The only thing what I will maybe add or have as an option then for the client. Just make here like a plastic thing that just cover maybe or if it's straight, it need to be have a limited switch. Let's say if this touch if it's straight, it touch the feet, the tractor will stop. Or design is going. Let's say have two bumpers like this. That if this guy is standing here, he will be pushed away, or the traction will be.
We made a vehicle that was the standard vehicle like this, and we make the wings something like this.
Yeah.
Okay, and in fact, it was nice because it was the standard vehicle with two wings on top.
Yeah, you can do this in plastic.
They called it the airplane AGV. It was called like that. But luckily, it was just running at 60 meters per minute. It could not take off. Okay, but because the wings was incredible, and that was just for that. We do this wings.
And even you can do this a little bit further. That is safety by design, or that is then the reason. In worst case scenario, it will.
In that case, considering that we were putting these new things, we also put bumper here, if I remember.
Yeah.
So that's another additional.
Yeah, for sure. It's what we actually. If you put a bumper here, it's also a good thing because then you are here. But also, if you only put the bumper here, just a flap like a sweeping flap, let's say, and this is connected with the switch here. The sweeping flap will tell us if here is a guy standing of a worker standing. So you can do this one, or you can have indeed the same a little bit like your design and cover it in one like a wing, and it pushes you away from the hazard, let's say. And in worst case scenario, it pushes you away from the hazard. In another scenario, the wheels start to spin and telling us it's something is happening here, what to do. And it's the same like here between the trolleys. In my opinion, if the wheel starts to spin, let's say more than 3 seconds, and the navigation is telling you that you are still on the same spot, your system should shut down and say, okay, this is not normal. I'm spinning, and the navigation, I'm not going forward. So
I want to speak, and I want you to speak now about the specific thing that we can find in the 3691 about the tow tractor. So I said the 3691 is for everybody, for all the vehicles.
AGVs, AMRs,
okay, but this section 4.10 is only talking about the specific track intended for tow trailer. So we are talking about this. today. So, Dave, what are the main specific things that the 3691 are saying about the tow tractors?
Yeah, these are the, let's say, the 4 specific things the 36914 is telling us what to do. Let's say with the minimum requirements, safety requirements in the standard. It says here before we start, we need to give a signal, optical or acoustic, for 2 seconds. Okay, this is mostly a common thing also in AGVs to have a signal before driving backwards or doing load transfer areas or something like that. So this is more or less the same way of thinking, just to show people in the area, okay, I'm traveling, I'm start moving, something will happen. And then they said the startup speed can be only at the first 5 seconds 0.3. That's also the same thing. So first acoustic signal to tell people, okay, I'm starting, I'm start to move, and then the first meters or the first 10 meters we do it in slow speed, so everybody can see also for the load maybe that it's not in full speed. That there's some safety.
And this is different from the other vehicles.
Yeah, this is different. Yeah, it's not a common thing to do this with the AGV.
I think it's also related to the fact that there is and we will see what is the main risk on there between the trolleys.
Yeah.
If it starts slow, if there is someone there between 2 trolleys, there are more opportunities to move, okay, to be out of there. So I think it's also thinking about this, to give the chance whoever is in between 2 trolleys
in the area
to move. Okay, because in the front of you have the laser scanner, so you are protected, but behind we will see if it starts running like hell. Okay, maybe the people.
And you are inside. The trailers or and so on. Yeah, maybe it's mostly in the. We see also in the environment zone and our risk assessment environment. We're mapping the zone. This will be for sure where he starts or where he loads or unloads the trailers. This will be a hazard operation zone, load transfer area. So anyway, there will need to be markings. There need to be maybe not a fence but some kind of sensors or toolboxes or trainings to check if people are indeed not walking between trailers or on trailers, sitting on trailers and like that. Yeah, that's for sure.
Then this standard also mentions something about the tow, no?
Yeah. Shall be fitted towing or coupled device. So sometimes the coupling it will be mechanical. Sometimes it's electronical with electrical or something that connecting automatically with the trailer or with the first trailer. It's possible, and we need to construct it in this way to reduce hazards connections, but they mean faulty connections. So you need, if you connect the trailers, or you need to connect the tow tractor with the trailer. It tells us, okay, see that this is not leading to a dangerous situation, hazardous situation. That is actually what is done.
Of course, the hook, okay, should withstand what are the forces. That's understandable and clear. Also, the pulling and everything has to be hooked. So and then also in the course we see that there we have the 3691, which is the one that the standard that is leading the mobile robots, but we have also the 1175 that provides more specific safety, conditions for specific, devices. No, in this case, what does it say for what regards the hook?
Yeah, indeed. In this one, we can talk about what we decoupling while traveling. We don't want to decouple while traveling because the trailers will maybe hurt something or get crash in installation or like that. So, and they tell us in industrial tractors the coupling need to be performance level B. The minimum is B. before the A for 4923A, it says decoupling caused by fault. This is a decoupling by fault. In this case, it says more about the electronical decoupling. So if you have an electronical way to connect to your trailers, it should be C. If you have the normal mechanical way, let's call it, or something operator need to do, or something like that, then it's B. So let's use the B system now, but that is what the standard 11675 is telling us. Is the minimum performance. This is also the lowest performance level. So it's actually, we will see this later in the next slide, how to solve this.
Okay, so what we are saying is that the mobile Robotics is 3691. Also considering this specific stuff about the tow tractor, about the convoy, okay, or the trailers, okay, that is given in that point that we saw before. The specific device that is the hook has to comply with this 1175. Okay, in this case, we ask, okay, the PLB. In one case, PLC. In the other case, if we do not know what is PLB, what PLC, this is what we also explain in the module. In one module, there is also an introduction on how to calculate this. What does it mean? The PL level or the performance level? What is the C level? Okay. So it's otherwise it can be found in internet. It's not any secret, okay? But just to understand that PLB is less, and we can see here, is less, let's say, restrictive. No, is, I mean, the safety level of the PLB is lower than the C, okay? Okay.
The quality of a solution, let's say a P performance level A, the quality of this solution of this safety device will be lower than a PLE of D version. So the PLD sensor is the most reliable, let's say, sensor, E-sensor. PLE sensor is the most reliable sensor there is in the world to buy today. A PLA device is just a normal lock or something else. So we are now indeed asking PLB. They are that's what they.
So the hook has to be PLB. Okay.
Yeah. It's also
PLB. See, if it is mechanical, you say PLC. If it is electrical.
Yeah. That's true. Also important, this slide is telling us. It says to us an unintended decoupling. So we need to check decoupling between the trailers, decoupling between the towing tractor and the trailer, caused by a fault in the electronic system shall be avoided. So if we put an electronic system to couple, that should be avoided. But also the B, decoupling of the trailer by the operator while traveling shall be also avoided. So also when an operator or the tow tractor is just driving, we need to have a system that is preventing this from that the trailers are decoupling during his travel path. That is very important because that is telling us what to do, when to do this, and indeed the performance level, how to do this.
But this kind of performance level of the hook is regardless if it is an automated vehicle or is a manual vehicle.
Yeah,
we are only talking about the hook.
Yeah, now you can discuss. This is the standard about, let's say, forklifts, about manned or unmanned vehicles. So also with the manned vehicle, sometimes you have the hybrid tractors. You have the same thing. They explain us also to have the PLB version to do this. Mm-hmm. But we will show this. This is indeed. It can be this. The hook can be this, a mechanical kind of system. And in this case, I used this as an example. It can be with spring or gravity. That it's telling us what not to do. So this one decoupling is we need to check if the decoupling cannot be the case. So in this case, or like a caravan. You have a caravan or a trailer, whatever. They have also always the same system. You couple something, but it will prevent us decouple just while driving. So you need some kind of system, mechanical, electronic, that this will be the case. In the performance level B, it's also important to say we don't need a DC, diagnostic coverage. What is DC? That is just, let's say, the system that is checking if we did the right thing. So sometimes if you go with PLC or PLD, you need to check if the safety is on, let's call it. That's more in the electronical part of it. But you need a diagnostic to check, is the like in this case, is the trailer or is the hook, is the trailer right on the hook in the right way. This is not for now the case in the PLB. We don't need diagnostic cover. So that's a good thing, let's say, in this case, because otherwise we need to have a sensor to check if the trailer is on this position. Now it's telling us, no, this is not needed. We have B, this one, B version. So something mechanical or whatever is enough to if it's done properly by an operator or by a system, the checking of this is good enough. So,
yeah, you are saying this, but I'm thinking about the automated solution, no? Okay.
Yeah, if you are
in the manual, but in the manual, maybe the operator takes somehow the responsibility or the awareness to check these things and to verify. The mobile robot is moving along, so we are putting, it seems to me, that the same type of safety level if it is automated or not.
Yeah.
So the requirement is the same, I mean.
Yeah, three things. You have three solutions for this hook, let's say. One is indeed you have the operator or something who hooks it, then it's done manually, then the hook is okay. You have maybe a system, this one in a digital version, an automatic version that this one is going automatically open to hook the trailers. Then we know we are on C. We need to have the performance level C that is telling us the standard. But no worries. Then we are here. The C version. It's category 1, and the only thing between category B and category 1 is the difference. It's also DC none. So it says we don't need diagnostic cover. So we don't need to put the sensor to check if the coupling is done right. Also in this case, the PLC version. The only thing the difference between the B and the C is that they call category 1, the C PLC version, is that you need to use well-tried components, and well-tried components are it's the same like a switch for your electricity to put a light on in your house. You know, the light switch. It's a well designed component, a well-tried component. They made it for this temperature, for this 230 volts or all this. They made the system specially mechanical or whatever system specially for this use. So this is the difference between here category B and category 1.
Okay.
Important to say also in this one, because we talk about simple design, let's say, it says minimum design, safety principles, it's over-dimensioned. So the hook should be over-dimensioned for the load, for the trailers, for the weight. And it need to be also expected, the operational stress, let's say, if we know there will be stress on the hook for the amount of trailers behind. So we need to do this design also. And also about influence, if we have vibrations for the floor or temperature difference between outside and inside, or need to go in a frigo or whatever it will be, we need to design this hook in this way that this will be the right hook for the right in the right position and also in the right So that's important to know that you have some minimum safety designs, let's say, to be in the performance level B or to have performance level C. But it can be all in the design.
So with this we have covered what is the vehicle, okay?
Yeah, the vehicle and the hook. Yeah, that's it.
The vehicle with this special attachment, which is the hook, according with the 175.
Yeah.
And this is a part of the, as we said, let's come back just a moment here, and we should be at this point here, okay?
Yeah, we are designing the hook for our towing tractor. Yeah.
Okay, so we are doing this, okay? Okay, we are doing this. Okay, now we have the vehicle that is safe or as safe as possible. Okay, and then we have to think that we are putting in an environment with other kind of potential risk. No.
Yeah, maybe trailers from the client, maybe with trailers from our company. It can be different.
We will not go now into detail about all the let's say environmental risk or risk working areas of the vehicles, because we saw in the module 7, for example, that we are talking about operating area, operating hazard area, restricted area, etc. That all depends on the safety distances between the moving vehicle and the structures. Okay, depends on that. Depends on the kind of safety device that they have. Okay, if it is depending on the PLD, or if it depends on the speed, depend on many things. Okay, but what is important to understand here is, depending on where the vehicle is working, there will be an associated risk, and the area will be defined as this is. And there are clear rules on how to define what is operating, what is hazard, what is restricted, what is confined. Okay, so if we go directly into the
this is one of the things you can do. Also the e-stop button, if you lower the speed or the speed is in this speed is possible to push the E button. Also, maybe you have 4 E buttons in this area that you are also on the back. You can you can push it, or another person can push the E button and see the accident happening. And so we have some design and some things to do. But I know in operation you need always to see on the field, because you have hundreds of scenarios.
There we are saying that you push maybe the people with these things, but maybe there is a column there, and there is a everything depends, you know.
That's true.
Go ahead, please.
Yeah, even if you have what you're telling us, this design, the wing design, let's call it, is also good for you. That if it's like a hybrid system, that the guy is not making too short corners or because if you say here is a column, that's not possible, because if there is a column, the cart will be.
Oh, in this case, yes. Okay.
Yeah, sometimes
the length of the tilt. That's true. That's true.
Carts, big carts.
Sure. That is every situation is completely different. So
that's the reason risk assessment environment will tell us what to do, and the severity of the of the scenario, the accident happen, can tell us also what to do, and it will be different between a 20-ton tractor and a 20-kilo tractor, let's say. For me, that's a difference. We saw this in the risk assessment.
Okay, Dave, if you agree, we see just a couple of video, okay, very short, just to comment what we have said until now. We're more or less the same, because the situations are there. Just 1 second, I put this video one, please, presentation. Where it is? It is the tow tractor. Here it is, okay. Okay, this is from YouTube. I will put the link so everybody can visit the full video, because I take some parts just to avoid remove the. Okay, here we have excuse me, because a factory with tow tractors.
Yeah.
Okay. There are quite a lot of them.
Quite a lot, yeah.
Okay. And we see, 1 second, I want to stop. Okay. You see here, can we see? Oh, see, cannot. Okay. In any case, we can see here, for example, I just put another color. Like it's easier to see. 1 second, red. Okay. We see that there is no anything preventing someone to get into the trailers. Okay, and there is no also, as we said, nothing that will stop it in case of someone is there. So it's a risk. I mean, when we talk about this, it's because we see it every day in the factories.
That's a risk. They put just a sign, don't step here or go.
These signs there. Okay, just clear.
And I see also they have some kind of line here, electronical line, maybe. I don't know what it's for, but I think they have some kind of just maybe this is the data to check if the load is on the right position. So that is possible. I think so, because otherwise, why you have a cable here? For me, it depends. The same thing. I see here a lot of these vehicles moving. Here also, everything is done by robots, let's say. And I think in this factory, there will be not so many people walking here. This is also the difference, like here in this hallway. Here you have a lot of space also for other vehicles, but also for people walking. I see here you have a crossover. So in my opinion, this is a factory where people are walking separate, here also separate from the vehicles. Okay, this is the case. This is the person detection.
Look here, you see here. In fact, here you have quite a lot of space.
Okay.
So also here you have a lot of space. So it's a well designed, let's say, layout.
And also if you, we told this also with the risk assessment, there is a difference between if you have 100 machines and 100 people working together, or you have 100 machines and 4 people working together. They are trained and so on. So we see this also in the future. They will and how they will work together. So here, in my opinion, the first opinion, let's say, they have separate, let's say, people from vehicles, and how this person will be inside of the moving trailers. It could happen. It's a scenario that we need to cover. But I think in this case, in first look, it looks. For me, good. This is done the normal person detection, let's say, so it stops because the laser.
Excuse me, Dave. This is what we said. I mean, this is for the video, of course, to show that the vehicles are stopping. They've done the test. Is supposed to be okay, of course, compliant. But this is what we said. Do you remember when we said? If it is safe, if it is PLD, there is one chance to stop that there is a problem between 100 million. I don't know, no?
For sure.
Avoid stopping the vehicle, because it's excuse me, it's not. I wouldn't say stupid, but if you have bad luck, this 1/1 million is yours.
That's true. Here is also very important to say the safety field here, the person detection. They should be as wide as the cards. So that is also one, because otherwise we have the scenario that you are standing here. That's what the scenario we were telling about earlier. These guys are not in the direction of the moving vehicle. So here you should have the field should be as wide as the cards, because otherwise it can pass you and then the cart will hit you. So from the backside, that's even worse than. So this is important to tell if you designed this vehicle that you design it for the carts they will need.
One question, because we saw, but I wanted to just very quickly to explain. When we do the risk, we do the evaluation, for example, for the safety scanner that is stopping in time. We define what are the conditions in terms of the floor, flatness, roughness. I don't know if there are several things that you have to comply with. When you go to the factory of the customer, if there is some kind of thing that is changing this situation, you should verify again that is not any problem. Imagine that this is a very slippery floor, so you should check at maximum speed, 110%, all the things that we saw in the module 6. That you have to verify again in the factory if you see that there is something different from the test.
The risk assessment is telling us also you have the zones, and then I said also we put the pinch points and also the interfaces. So here we have actually let's call it an interface with a trailer at some model of trailer. So here we need to make sure if we connecting this trailer that our field is covering the trailer field. And I think also personal that these flaps, let's say, they prevent also that the guy is going not under the cart. The only hazard here is still between the carts, but then it's what we said in the beginning. Then you're walking in the path of the vehicle. You're walking here. The vehicle is passing, and then you decide to willingly, let's say, put your feet inside the two carts. Okay, this is a scenario, but then we need to cover it by calculation. How many people are working there? How many times they are inside?
It's a calculation of probability.
Yeah. That's true. And I think maybe even these are electronic. It's maybe not electronical. But
but I think because the yellow one is the mother, okay. There are the blue ones that are the son, and this stuff is moving up and down to remove the blue trolleys.
Yeah. That's possible. But I think the flaps, they are doing something. Maybe they are also electronical covered that if somebody is pushing this flap on before the wheel. That it's possible that they are connected with the wire. I don't know this system, but it could be.
This is another video. Okay, I just wanted to show you this backwards movement without any type of safety. I mean, there is no safety scanner. There is nothing there. It's true that it's done very, very slow. Okay, so I don't know what is the rule here.
Yeah.
There is just the hook, it's just going and then hooking and then moving.
Yeah.
Always the same problem of the space here. The space between trolleys is the space between trolleys is typical, okay? But in this case, just to say, because in some occasions and more because the technology is allowing more to do this, is to hook the automatically, which in the past was a problem. In the past was a problem because the reliability of the stop, etc., was complex. Now they are more intelligent; they can correct. So, but when you are going backwards and you are going to hook automatically, there was no bumper, there was nothing there.
No, that's true. Normally, you can mute if in the according to 3691. So
we saw you can mute with this 180.
Yeah, you can mute, and you need the speed was 0.3, and you need to have floor marking or restricted area and so on. So it is possible. Let's say this solution, maybe I don't know but it's possible to have in a muted situation like this going backwards. Okay, I'm not telling it's the best thing to do, and we saw already this is an electronical lock device that should be at performance level C because it's an electronical. So this machine should be performance level C, but the end client, let's say the end user, should mark this as a hazard area anyway.
At least to put here some kind of
for sure a sticker or saying this guy cannot standing here. This guy should be trained or have a video or whatever that he knows what is going on and that this is a muted situation, that he's not can stand here. And here should be also then for sure a e-stop button, because that is also what telling muting or the speed telling us. If you're
no, there is not a muting. There is not. You see?
No.
There is nothing behind. Should be something behind. You mean?
Yeah, because speed you can mute with low speed, but it can only be that you have the time to be outside of the hazard or push the button. Let's say I was here working and this vehicle coming towards me. I don't know what's going on. I should could stop it immediately and not escaping or whatever. That's for me the minimum in this case.
Okay. Now there is just another short video. Let's go ahead. Where is okay? Okay, 1 second. It's finishing. We have always the problem between the trolleys that when we saw.
Yeah. This is one done by design is a little bit because the trolleys are closer to each other.
That's true.
Actually, it's not so.
Look, this is another way to
put them closer and
the problem is you have a wider turning radius. Okay, you need, because otherwise they touch batteries. If you want to make safer, you have to put. That's a good point. Also, narrow the tilt.
That's also by design. Let's say.
Yes. And then I wanted also to show you this because it's clearly showing this is a huge.
For me,
wider, and this is an outdoor case, okay, but it's much wider than the vehicle in this case, much wider. And here we are not talking about 1 or 2 tons. We are talking there are a few tons behind.
Here you don't want to be between this one.
Look here.
That's dangerous. If you're standing there and the vehicle will throw you on the ground and drive over you. So for me, I don't know how. That's my opinion. But this is very dangerous. I will say confined space, and you need to do something on the area. Nobody can be there. You see already a guy here. Driving with other vehicles. It looks like a nice solution, but I don't think safety-wise, I will not advise this.
No, I mean, it is, you can manage. I mean, that in that case, for example, you saw there are the cabins, these cabins, I guess they are put and remove from the trailers. They are not hooking and hooking the trailer every time, I guess. You can create the trolleys that are connected to the AGV. So you are doing the PL or the safety in all the area. Putting also here behind. There is no. 1 second. Here, so safety button, safety here. There are many things to do on those trailers.
For sure. If this laser field is not big enough and I'm trapped between it, or I'm standing here in this area, or I'm in this area, and this is not. You can't say this is safety by design, and this is not safety by design. This is a little bit. I don't know if this is a LiDAR or something that
for navigation,
maybe for only navigation, that is not and here the only solution, in my opinion, if you want this solution, is here area that no one can walk between, and so you need to fence it or have a sensor or whatever.
Look how long is this
for sure. This is and indeed it's also outside, so for lasers, it's also difficult to detect persons outside.
But there you are in another field, because you are talking about the performance of the safety of the
but
be compliant with the outdoor, etc.
Here also, you can get under this design, and the other one was so low, so you can between. You can go between
here to cover wheels.
Here
there are many things you can do, or to cover at least to cover this. To put something.
Also, they ask for round design, so you need to round.
This is corner, like completely corner. This is not a corner. I understand. It's just like
place wings.
It's an edge.
For sure. For me, if it's all the time the same thing, what they are doing now, getting the truck cabin from another place, maybe from over street or something like that, then you can design this one also safe. If it's always the same cart and the same two cabins, let's say, to get from A to B. Just if this is not 100% safe, make then this 100% safe, and just add here a data cable, put here a laser or whatever or something, or design it in this way that you can't enter it and you can't enter between these two carts. Okay, the carts will be costly, but it's the only solution, in my opinion, to cover this one, or remove people from this area. But this is almost
you said Dave, you said that the cards will be costly, okay? But we saw in the module 1, the very beginning, so the liabilities, etc. Someone would be responsible for that. I mean, typically, or the CEO, or whoever in the risk in the factory of the end user, you know. So the one that is taking this responsibility. So yeah, it's a cost. Everybody, and it's a question of deciding. It's your responsibility who is using that. If you are willing to afford this risk, it's your problem.
Yeah, that's true. That's the environment, and indeed, that is a risk I don't want to take. But because you see this already, you see even a child, let's say, can see, or a normal worker without experience can see, this is dangerous. There are a lot of tons here moving in an autonomous way. I need to take care.
By the way, I don't want to make because maybe this constructor, the AGV is great, is working in outdoor. It seems very nice. Okay, there are only things to do in the specific applications. Okay, I don't want to say that this is and who knows, maybe one other thing that is another disclaimer. Maybe this specific supplier of mobile robot has not installed this vehicle and has done another person. So it is not against this specific company. Okay?
No, for sure.
It's just a question. We are evaluating this.
This situation and especially the cards, because we don't know the AGV if he has the laser field, the machine safety. It's what we said in the beginning. You're doing test A, test B.
That's all. I mean, we are just evaluating what we can see in the video, and we don't know who's responsible, who has installed. We are thinking just that there are things that could be done better.